Okay, looking at question 1 of paper 3, talks about a cumulative distribution function which it gives me. The thing that I need to remember is that the cumulative distribution function gives me the probability that x is less than or equal to a particular number. That's what this function tells me. So in question 1, when it asks me for the probability of x being bigger than 0.75, I know that if I write this the other way around, 1 minus x less than 0.75, I can get the less than from this function. So as soon as I've got that, I can just throw 0.75 into the function here, and I get my appropriate answer. There. So that's the probability of x being bigger than 0.75. Perhaps one point that's worth noticing here is that because this is a continuous random variable, the probability of x being less than x is the same as x being less than or equal to x. That's for continuous random variables. Of course, if it's discrete, that's quite different. But in this case, there's your solution to part 1. For part 2, ask me to find the lower quartile. I need to know that the lower quartile, of course, is the number by which 25% of the probability is lower than that. So it matches. So I'm just looking for the value that goes into this that gives me a probability of a quarter. So I can put that into the function, and I'm not going to try and solve that. I'm going to use that on my GDC, either graphically or probably more efficiently, numerical solve will give me that answer straight away. Moving on to the next part. I need to be aware that when I'm finding continuous distribution functions, I start with the probability distribution and I integrate to find the area. Now, if I'm then given this, I want to get back to the original distribution function, then I'm going to differentiate. So in part B, part 1, it asks me to find the probability density function. I know that I'm going to differentiate this. I know that that's a product, so I set up my product rule, I throw it in, and that result comes out quite quickly as the required result. On to part 2 then, finding the mean and the variance. These are standard formulas for a continuous distribution. E of x is the integral. The only interesting part of this function is between 1 and 0. It's 0 everywhere else. So my limits are 1 and 0. I can put this straight into my calculator as long as I've got an appropriate integral statement and get the answer. And the same for the variance. I know that it's x squared f of x between the limits of 1 and 0. Don't forget to subtract the mean squared and you get the result for variance there. So that's your answer for question 1.